So welcome everyone, welcome to the September edition of the monthly OpenLineage DSC meeting. As a reminder, this is recorded. You can find the notes, the recording of the meeting on the OpenLineage wiki, on the LFA and Data Foundation wiki, and in there. So we start these meetings with doing a quick introduction of people attending the meeting. So if you could do a quick, just state your name and why you're attending. And if we end the meeting with an open discussion session. So if there's something you'd like to be discussed, an agenda item you wanted to add to today's meeting, feel free to state it. And if you're new and you just wanted to listen in, this is also fine, right? You don't have to have something to talk about. So I'll go following my screen left to right. So Peter Hayek, and please let me know if I'm pronouncing your name properly. You're muted.
Yes, you spelled my name perfectly. Hello, everybody. I'm Petr. I work for MANTA, and today I will be talking about MANTA and about integration between MANTA and OpenLineage and all these things.
Nice. Next is myself. I'm Julian. I'm Chief Architect at Astronomer, and I'm the lead for OpenLineage. And today I don't have a topic to discuss, so just like facilitating the open discussion. Michael Robinson, you want to go next?
Yeah, hi, I'm a developer relations engineer at Astronomer. I support the community and coordinate these meetings. So I'm here, taking notes, and I'll be talking about releases momentarily.
Peter Hicks.
Hello, I'm Peter. I'm a software engineer at Astronomer, and I'm a Marquez contributor.
Minkyu.
Hi, I'm Minkyu, and I am a software developer at Astronomer and also contributor to Marquez and OpenLineage. And good to see you all.
Benji.
Hey everyone, I'm Benji. I'm an airflow engineering advocate at Astronomer, and I'm here to talk a bit about the new SQL check operators in the SQL common provider in Airflow and how those were designed with OpenLineage in mind.
Ernie.
Hi everyone, Ernie Ostick. I lead the products group over at MANTA, and we're very excited to share with you the research that we've been doing and where we're headed.
Nice. Jakub.
Hello, everyone. I'm Jakub, software architect at MANTA, and I'm very excited to hear all the OpenLineage news and, of course, Petr's presentation.
Mandy.
Hello, everybody. I'm Mandy Chessel. I'm the leader of the Juria project and also a contributor to OpenLineage. And today I will just be listening.
Will.
Hi, everybody. I'm Will Johnson. I am a contributor to OpenLineage and a member of a team at Microsoft working with OpenLineage integration into our Microsoft Purview product.
Howard.
Hello, I'm Howard Yu. I'm a staff product manager here in Astronomer, working in observability team. Nice to meet you all.
Suparna.
Hi. So I'm Suparna. I work in the Hewlett-Packard's labs, which is the research group in HP, and I'm part of the AI research lab there. So we have been working on the common metadata framework for AI, and Anne-Marie is also on the call here. And we've also been, looking at OpenLineage. We're actually working with using OpenLineage to connect from this common metadata framework layer and connected to a data catalog as part of a project that we are working on. And we're very happy to be to join this call in this community. I talked to Mandy some time back, and we had some, we were running into some issues or some questions in terms of how to work with data facets in OpenLineage and static data facets in particular. So we have some ideas as well that maybe we want to discuss at a future call. Thanks.
Welcome. And yes, we'd be very happy to hear your thoughts about those. That sounds great. Willie?
Yeah, hello everyone. I'm Willie. I am the co-creator of Marquez. I'm also a committer to OpenLineage, and I'm part of Astronomer, so I work on the observability product.
Anne?
Hi. So I work with Hewlett-Packard Enterprises in the labs in the research wing. So I work on common metadata framework. And as Suparna said, we are looking forward to using OpenLineage as a mechanism to export metadata from common metadata framework and import into Data Hub or another or data catalog tools. So looking forward to this community to learn more about OpenLineage. Thank you.
Welcome. Harald?
Hi everyone. I'm the engineering manager on the observability team, Astronomer. For the next hour, I'll mostly be tuning in since I'm also watching this guy who can't go to daycare today. So really looking forward to hear about everyone's updates.
Hi, Dylan. And Michael Collado.
Hi there, Mike Collado. I'm a staff software engineer at Astronomer. I work on the observability product, and I'm also a contributor to OpenLineage and to Marquez as well.
And last but not the least is John.
Hey guys, my name is John Thomas. I'm a developer relations engineer here at Astronomer. I primarily work with the Airflow community and provide auxiliary support to OpenLineage and Marquez.
Thank you all. And so the next slide is just a reminder of the main mean of communication outside of this meeting. So the main discussions happen on the Slack, the OpenLineage Slack. You can join through this link. There's also a mailing list that has been mostly kind of distributing information. There's the OpenLineage wiki when you'll find the history of all the meetings. And if you want to see updates and we tweet about releases and so on the Twitter and YouTube and so on. On the agenda today, so we'll start with the announcement. Michael Robinson is going to talk about the current announcements and recent releases and what's in them. Then we'll switch to Benji. We'll talk about the extractor that you mentioned earlier. And then MANTA will do a presentation of their work with OpenLineage. And we finish with open discussion if there's any topic. So feel free to also ask questions when you get there. So on that, Michael, I'll let you take it over.
Yeah, and before we get into recent releases, does anybody on the call have an announcement that you'd like to share? Okay, if something occurs to you that you'd like to share or ask about, open discussion is another opportunity to do that. And I'm going to jump right into our releases. There's an additional one here. I didn't update the slide in time. 14.1. Going to just try to move through these quickly because there have been so many changes to the project since our last meeting. I'll start with 13.0. Headline here, changes to Airflow and spec. We added support for proper dynamic class inheritance in the Airflow integration, specifically the BigQuery extractor. We now differentiate between databases and schemas in SQL extractors. and that's also in Airflow. We implemented JSON encodable objects. In other words, we are now converting task objects to JSON encodables in Airflow. And Airflow users can now create OpenLineage dataset classes directly in DAGs. So thank you to Connor and Minkyu and Jakob and Benji for those changes to Airflow. We had a couple changes to the Flink and Spark integrations as well. I want to welcome new contributor Hannah. So nice to have you. We now have a new interface. It's a relation handler to support Spark data sources that do not have a number of properties set, which is the case with the Azure Cosmos DB Spark connector. And in Flink, we have a new running event type to track running Flink jobs, I believe, and to convert those from other to this new type. So those are the integrations. Moving right on to our changes to the spec, we are now capturing ownership in 13.0 still, and we have the running event type in spec, and we have a new symlinks dataset facet in the spec as well. So thanks to Julian and Mariusz and Pavel for those changes to spec. Also have a new feature in the proxy. We have an HTTP lineage stream that forwards any given OpenLineage event to an endpoint. So thank you, Howard, for that. Just a couple changes to tell you about in 13.1, some fixes to Airflow. There was a discrepancy between the spec and the way we were talking about the parent-child relationship, I believe. So thanks, Minkyu, for that, and Jakob for fixing this issue with the on-running hook. And a number of things in 13.2. The headline here is Spark, a lot of changes to Spark here. We have an extract dataset identifier that pulls out the path on the HDFS compliant file system. We have a Custo relation visitor. We have support for DBT 1.3 beta's metadata changes. And we have the new symlink dataset facet added to Spark. We also have timeout that's configurable by the user. So those changes are to Spark. Thanks Tomasz, Pavel, Maciej, Hannah again, and Will for those changes. Moving on, we have a new column level lineage facet doc in docs. I'm still in, I'm still in 14.0. And what else do we have here? Support for a new version of Flink and support for the SQL dialect in Redshift. So thank you to Maciej and Mariusz for those changes, and to a fix by Mike to the Great Expectation SQL parser, I think. So I did have just an update about 14.1. This one got stuck in the tube, as Ross Turk said in memorable fashion. And an important fix here, it was complete except for the Java client, and we're going to have that hopefully complete and released in its entirety in a couple days. So thanks for your patience with that lengthy overview of our releases since the last month.
And apologies for not interpreting the cues properly on going to the next slide.
My bad, I was all over the place.
And I think the release is currently incomplete. There was a bit of an outage with the Nexus repository, I think, like something, but this is in progress, and that should go through. So thank you very much, Michael, for the overview on the release, and there's been quite some activity this month. And so for the next step, we'll have Benji talking about Airflow data, native data quality in Airflow and OpenLineage. And Benji, do you want to take over sharing? You're muted, Benji.
Oh, sorry, I was muted. Yes, I would like to take over the screen. Thanks. Started the video, did not start the audio. So I actually gave a webinar about this yesterday, and the recording is going to be available soon if it isn't already. So if you want to see the full webinar, that's available as well. But basically, I'll give a very brief version of it here because the webinar was almost an hour. So the idea here is we're looking at data quality with Airflow. There are a few reasons we like using Airflow for data quality because we can have all of our checks happening within the pipeline. We can get immediate alerting, and we have a lot of different ways we can do that alerting. And of course, we have lineage support now with OpenLineage, and that gives us its own very beneficial elements. So the data quality use case that we're really looking at with these operators are static checks. This is similar to SOTA-SQL or DBT tests or Great Expectations in that you are writing out by hand a set of tests that will be evaluated to a Boolean true or false, which you can then see if they passed or failed. These static checks are a little bit limited right now, but they do allow us to do things like figure out if columns are the correct type. If we have data in certain ranges, say we want to make sure that we don't have negative numbers and we want all of our values to be less than 1,000, we can give that integer range. And we can also do some date ranges as well. We're not really going to talk about metrics or anomaly detection here. So let's move on to the meat of this. What are these new operators? What do they do? Why are they important? So we have a new provider, which is a common SQL provider. This will allow us to update these operators at the cadence of provider releases, which in Airflow is much faster than the at best quarterly Airflow releases, as the SQL operators before were under the Airflow project proper. So this basically just lets us iterate more quickly, which is great in and of itself. The supported DBs right now are all the ones that use DB API hooks. So that's a lot of the most common ones out there. It does not currently support BigQuery, but there is a fix for that on the Astronomer side that we're working on getting released as soon as possible. So we should have BigQuery support very soon. Within this common SQL provider, we have two operators, the SQL column check operator and the SQL table check operator. And we're going to dive a little more deeply into both of these. The SQL column check operator is what I call an on-rails operator. Instead of providing some arbitrary SQL query, you give it what I call a column mapping, which is just a dictionary that relates every column to a set of checks. Now you aren't limited to the number of columns or the number of checks per column in this mapping. This example only shows one column, but you could have 2, 3, 4, as many as exist in the table. And within each column, you can have multiple checks for each one. We'll look a little bit deeper into what these things mean. So we have here the ID is running a null check. This equal to 0 means that we expect 0 nulls, and we have a tolerance, which is a percentage. So if this equal to was say 10, and we had a tolerance of 0.1, 10%, then we would allow for one extra null value or one fewer null value. So even though the equal to is 10, a value of 9 or a value of 11 would still pass the check. And this operator also supports some partitioning, so we can essentially use a where clause to sort the data by date or whatever other field is relevant here. Now, an important thing to note with these SQL check operators, they don't support data frames. They are purely SQL. And as we'll see here, the available checks were actually written to this current OpenLineage UI specifications. So the only available checks are ones that will show up in the OpenLineage UI in those actual UI fields. And we'll see what those are, what that actually looks like in just a minute. So these available checks, as we see, are a min, a max, a unique check, a distinct check, and a null check. And we have different qualifiers that we can use, like we saw that equal to. We can also do the other 4 common operations here. The SQL table check operator is a little more flexible. It allows us to use more of a SQL query structure, but you're not just writing arbitrary SQL. If you did write arbitrary SQL, it would be very hard for the OpenLineage side to parse sometimes, because you wouldn't necessarily have to alias your result to a check name, and we could run into all sorts of issues actually trying to parse that SQL statement and display it in the OpenLineage UI. So again, the SQL table check operator was written with the OpenLineage UI in mind. And so the checks dictionary is structured in a specific way. The checks allow for arbitrary check names, but that top level of the dictionary are just going to be the check names. So we have a sane way for the OpenLineage UI and the backend to be able to parse these and create the correct data quality facets, sorry. Within the row count check, there's only one one key value pair that you put in the dictionary per check. And the key is always the check statement. And then the value is simply the SQL statement that you would like to write there. So in this case, we're doing a row count check, and we're checking that there's one row in the table. Not super exciting, but it gets the point across. Now, like the column check operator, we can have multiple checks that are written for the table. And the way the table check operator works under the hood is it'll send one SQL query that will query the database with a bunch of select statements that are union all together. So it'll only send one query to the database, and then it'll receive back a data frame that has two columns, one with the check names and one with the check results, and then one row per check. So if we had 10 checks in the operator, we would get a data frame back with 10 rows and 2 columns. This is pretty manageable for Airflow that isn't supposed to process a lot of data locally. So we can handle all of that on the Airflow side. The SQL column check operator will send one query per column. So if you want to do parallel operations with the SQL column check operator, you would have to write, you'd have to have an operator per column currently. So we see, what is this operator useful for? Is we can do row count checks, we can do schema checks, we can do comparisons between multiple columns. This one essentially lets us have a little more flexibility in what we're looking at and covers a lot of bases that the column check operator doesn't currently. And this is the point where I did the demo. So I can just really quickly show what this looks like. On the Airflow side, we have what I call the complex snowflake transform graph here. We create a table, we load data to 2 of the tables. We do our first round of quality checks, and then we load to this combination table of the first 2. We do another set of quality checks on this combination table, and then we perform our business logic transform and we clean up. So with all of that said, what this actually looks like in OpenLineage is a little more complex because we have our data sets in order. And we can see here in the quality tab that we are getting those results, which previously no operator in Airflow was designed to do this. So while there was an ability for Airflow integration here, and while you would get information from operators, you weren't getting any data quality information directly from the operators. You would only really get it if you're using the Great Expectations operator. But that was the Great Expectations project integrating with OpenLineage under the hood. It wasn't actually directly through Airflow or really had anything to do with Airflow. So this is the first time that we're seeing Airflow operators proper provide data quality data to OpenLineage, which I think is a pretty big deal. And we see that the columns here, as we would expect, are giving us our lineage. We can see that we have a min check, a null check, and another min check down here. And I think this last one is a min check as well. So again, as an example, it's not too terribly thrilling in the complexity of the data that we're seeing, but as a proof of concept, it shows that this is working. And this is, I think, a very viable way forward towards how we can make the integration between Airflow and OpenLineage much more robust. So that's the demo, everyone. Can do questions now or later, depending on the flow of the meeting.
Thank you, Benji. I think we can do some questions. So I just wanted to clarify one bit of information. So the UI you showed is the product, actually. So it's our commercial product, right? And this UI is part of the Astro product. All the data is collected in OpenLineage and stored in Marquez, and people can build things on top of it. But this specific UI that Benji showed is not part of the open source stack. But it's just the presentation part of this. So it's like part of the added value we build in the Astronomer product that we show.
So do you have a sample of how the OpenLineage output for this looks?
I'm not sure what you mean by that. Do you mean like the packets or like the Marquez side?
The OpenLineage, yeah, the OpenLineage packets. So
I have, well, we can look. I might need Mike or Ross or someone to chime in if this is correct. Is that metrics in the network, that metrics packet, the same thing? Or is that something else?
Yes. So
Yeah,
there's go ahead.
Sorry, are you talking about the API response that you show in the Astro UI? Is that what you mean, Benji?
In the Datakin UI, when we did that inspect element with the metrics, is that?
Yeah, it is not.
No,
it is not the same.
Okay.
I think we're talking about the facets that the Airflow integration produces.
I believe the operative question
it's
is
a quality facets, I guess.
Oh,
Yes.
yeah, I can share a link to those data quality facets, but the data quality facets that are being filled are the standard OpenLineage data quality facets. No new ones were written for this.
And does it update those facets by making a new run event on an existing job, or is it updating the job with the data set in place?
I believe the latter. So for each operator, there's just an extractor, and that extractor will pull that data and fill the data quality facets.
But I think the SQL check operator itself ends up as a job, right?
Mm. Yes.
Yeah.
The job attached to the data set that it's updating.
Yeah. So the way that
SQL check operator would be a job, and it would have an input data set as the table that it's auditing, right, Benji?
Yes.
Yeah. So in Marquez, what we'll do is we will, so those facets are attached to a run, and that run is always attached to a specific data set version. So whenever a data set gets created in Marquez, it always has a version. And so whenever that data set is read by a run, we just kind of assume that it's reading the latest version unless we're told otherwise. So when those input data set facets are attached to the run, but then if you query the data set itself from Marquez, we will find all of the facets that are attached to that data set version. So whether the run wrote the data set and attached those facets, or if it read that data set version and attached those facets, we'll collect all of those facets and we will display them alongside the data set for that version.
Okay. So, and I posted in this chat some examples of what the data quality facet look like. So if there's no other question, we can move to the next topic, which is the MANTA integration and using OpenLineage. And thank you very much, Benji. That was a great presentation. I think we'll add to the link to your webinar in the notes so people can go look at it as well.
Thanks, Julian. Thanks, everyone.
So, Petr, do you want to take over sharing?
Yes, please. If you can hand it over to me. Yeah. And I think Ernie would like to have some introduction before I start with my presentation, right?
Yeah,
Please
sure. So I just wanted to thank everybody for giving this opportunity. Here at MANTA Software, what we do is lineage, and we started this project doing research into OpenLineage a while back, and realized that this is something that we want to be able to do to augment lineage for our customers, and also be able to give back to the community as far as lineage expertise and experience. And Petr is going to present. Petr is our lead architect on this project, and I'm going to let him take it away as to the things that we're working on and considering, and where we are right now. Thanks. Go ahead, Petr.
Okay, thank you very much. And I will tell you something about MANTA in general. And I hope that you heard about MANTA tool already. And I will just highlight what MANTA, and especially the MANTA Flow tool, is unique at. And I have to say that this is a unique column-level lineage parser of most data technologies. To be honest, I cannot even list all of these technologies, but these are all the relational databases, all major big data technologies, reporting tools, and so on. And what MANTA does is that MANTA can take the code behind solutions built in these technologies, like typically, let's say the Oracle PL/SQL code and so on, and it parses the code to the least, atomic level, the very, very detailed atomic level, and it constructs its own graph database. It's kind of network, it's database made of nodes and edges, and it is able to reconstruct very detailed column level lineage just based on the analysis, static analysis of the code. And as I already mentioned, it's primarily focused on a code-based lineage. So it was a bit difficult maybe for us at the beginning to become compatible with the runtime lineage, which is presented by OpenLineage model. But I will show you that it eventually was not a problem for us. And I would like to introduce one more term here, which is what I call enterprise level data lineage and its analysis and visualization. I will share this picture, which is a graph schema which shows high-level dependencies among different technologies. It's from a real project, from a real customer, and it's very, on an aggregated level, it shows dependencies, how many interactions, how many individual data flows are there among objects in these technologies. So you can see Oracle, ODI, Hive, MS SQL, PostgreSQL, and so on and so on. And all these lines, they represent either direct or indirect dependencies among these objects. And if this picture was of a better quality, you would even see that there are numbers. There are like huge numbers, like thousands of individual dependencies. And it shows, how interconnected the solutions in large, robust companies are. And this is what we call enterprise level data lineage. And it means that we need to be able to scan different technologies which were used in that specific company to trace dependencies, the data lineage flows, and so on, which means that we need to be able to connect to almost any technology which a customer could have used, and to be able to decode it, to understand the lineage, and then integrate metadata and show it in our visualization tool. So in most of the cases, the integrations or connections from MANTA to those technologies is done using what we call MANTA connectors. So here are some examples, like for Hadoop, for Oracle, Cognos, Tableau. We have very good connectors to these technologies, which means that we can do kind of reverse engineering of whatever is coded in these technologies, and we can translate it on a very detailed atomic level to this graph structure, Actually, this is Neo4j database, which is underlying database where MANTA repository is stored. And based on this graph database or data in this graph database, we can draw and we can visualize the lineage and the dependencies. And now we are trying to create new connectors for other technologies. Like, for example, we are also now working on a connector for Databricks. And we are working on a generic connector, which would use OpenLineage in order to be able to analyze and retrieve the data lineage of any OpenLineage producer. In this case, I used Kebula, which is one of the technologies which is already integrated with OpenLineage, and we use Kebula for testing of our connectors and even experimenting with some extensions of OpenLineage format for various purposes. I will talk more about it a bit later. So this is, the enterprise level integrations, which means that we need to connect almost any possible technology which can be used at the client's or customer's side. And now something about OpenLineage. We started with some prototypes for selected OpenLineage producers, and we simply took the OpenLineage which was represented in JSON files according to OpenLineage model. And we created very simple mapping and a simple connector which translates these JSON files into MANTA repository model. And it is possible to simply draw or visualize the lineage inside of MANTA visualization tool. As you know, at the moment, the standard OpenLineage model is more or less limited to table level lineage. I know that there are already solutions to extend for column level using specific facets, but the very basic model of these main entities, it goes only on the level of table and job and datasets dependencies. And in this very simple prototype that we started with, we used MANTA only for a visualization of what was there already present in these OpenLineage JSON files. Then we learned that for some technologies, it would be easier for us to already reuse what was done, for example, in Marquez project. So for some technologies, and we tested it specifically on Airflow, we use Marquez libraries, and we take the specific Marquez model, which is again expressed in JSON files, and we again translate it into MANTA. And I will maybe tell you something more about this very simple generic MANTA repository model. I already mentioned that this is implemented in JSON in Neo4j. This is graph database, and there are few entities in this in this model. First entity type is nodes. These are you know how graph databases look like. So nodes they are used to represent hierarchically organized objects, like for example databases, schemas, tables, columns, or for ETL, for data transformations, there are packages, procedures, individual commands, and so on. So these nodes are hierarchically organized themselves, and then we have edges. In MANTA, we draw the edges or relationships which represent the dependencies on the lowest hierarchical level, which means on the leaf level, which means typically on columns. So MANTA is primarily focused on column level dependencies, and we draw and we physically record these dependencies on the leaf nodes, which means on the columns. We can somehow deduct or deduce, how to say properly, some other dependencies on higher levels, like table to table. But as I said, primarily we store it on column level. Then we have levels of attributes, and we can draw attributes to these edges and nodes. So each node and each edge can have its own attributes carrying some more information. Moreover, we have layers, which means that these nodes can be organized in layers. In most of the cases, we use what we call physical layer. So all these, nodes like tables, schemas, and so on, they are organized in a physical layer. Then we can recognize also logical layer. If we, for example, take metadata from like Power Designer or other technologies. And now, starting with OpenLineage, we started with what we call runtime layer, so specific or OpenLineage layer in MANTA. And we are trying to combine or somehow integrate these these layers all together. And we are still deciding what will be better, if we will put everything from OpenLineage model into our physical layer, or if we are going to combine it. So we are still testing, and we are still like considering what is a better solution. Okay, and then resources. This is the last entity type to be mentioned in the model. Resources, they are used to somehow distinguish the sources of metadata. So for example, if we scan Oracle database, then the resource is called Oracle. If it's SQL Server and so on, if it is maybe data stage, whatever. So all the connectors, they are represented by what we call resources. Okay. And now how it looks if we translate something from OpenLineage to MANTA. I can show you even the live demo, but in general, as I said, we have the layer, which is OpenLineage in this case, and then we have assets. In this example, these assets were taken from Kebula, and I have assets like we can see data sets and jobs, so the main entities from OpenLineage model. I can select these for further visualization, and on the next slide, this is the visualization of my table level lineage. So there are some jobs, then there are some runs, procedures. I have data sets, if I see it correctly, and I can draw the lineage here. And if I go further, I will describe the way how we would like to achieve column level. So in this case, we can translate the standard OpenLineage model into MANTA for table level. And the truth is that if there is OpenLineage producer, which already provides column level lineage, we would be also able to take this column level, information about the column level dependencies, to take it from specific facets. This is not a problem. But we still see that there are many OpenLineage producers who cannot provide the column level dependencies, the information on column level. So we would like to, benefit from what is the highest added value of MANTA, and this is the power of all these connectors and parsers of different technologies. So the idea here is to extend the column, to extend the OpenLineage model, the standard model for a specific facet extension to be able to hand over the original source code of a ETL job or procedure or any other transformation algorithm from the original OpenLineage producer, and to encode it into the JSON files, still according to the OpenLineage model, but in the extension of a specific facet, hand it over to MANTA, and do this, what I mentioned already at the beginning, the reverse engineering of the code to somehow analyze it retrieve column level lineage, which is not represented in the standard OpenLineage model, retrieve it and combine it in MANTA repository, which means combine the table level dependencies information from standard OpenLineage model and the analyzed, reversely engineered column level lineage from the original scripts, which were handed over to MANTA in specific JSON facet. So this is an example how it would look like. This is a chop facet, which is extended here. And you see that there is a simple source code. It's a SQL query, which is encoded using the base 64 encryption. The advantage is that it doesn't contain any special characters, so it can easily be added into JSON file. And it's encoded here, and then MANTA decodes this source code, applies the reverse engineering algorithm for a specific programming language. So in this example, it would be PL/SQL. So PL/SQL parser within MANTA would be used to analyze the column level dependencies represented in this decoded code, and then it would be stored in MANTA and integrated with other metadata in the repository, and then we can visualize, as we can see in this example in this picture, that we already draw the column level dependencies among different tables or data sets and so on. So this way we would achieve what we are still missing in most of the connectors or integrations for OpenLineage producers, and this is column level. So what MANTA does is reverse engineering of the code. Of course, for SQL code, it's 100% working, but for many other programming languages, we are also achieving almost 100% accuracy in the parsing, and we can retrieve column level dependencies very easily from almost any technology which can be parsed by MANTA. And still, this would be done using the standard OpenLineage model, just with the extension for handing over the original source code of a specific job or data transformation and so on. And we are now working on this. This is a concept. We are now developing the connectors for OpenLineage. We are testing with specific technologies, namely we are using Kabula, which I already mentioned, and we are working on different scenarios for integration. We can either pull the OpenLineage from that producer, or we can push it from OpenLineage producer to MANTA, either using files repository, or we can push it to a specific API endpoint and directly retrieve this in MANTA. So we believe that this way we will significantly enlarge the number of technologies which can be integrated with MANTA using the standard, or be it a bit extended, yes, but mostly standard OpenLineage format. And this way we could be able to really integrate with significantly higher number of newly added technologies. So MANTA and these new technologies would be fully integrated. So basically, that's it. I hope that it was clear for you to explain, what is the intention and what we are working on. And if you have any questions, I'm ready to answer.
This is great. Thank you for sharing what you've been doing, and welcome to the community. And I think we've been curious to hear about what you've been working on for a long time. This is great.
Mm-hmm.
Any questions?
Yeah, I have a question. So you're loading via JSON files. Is that the normal way that MANTA works, or is this a sort of special for OpenLineage?
It's yes, MANTA is primarily focused on static code analysis. So it's in many cases it's handed over to MANTA in the form of files. You know, it's but as I mentioned, we are now working on different scenarios. One of them is handing over the files, JSON files, or we are working with API. Either we will pull it from the original OpenLineage producer, installing specific libraries like these listeners at the OpenLineage producer side, or if there are producers, like for example, already mentioned Kebula, they can push OpenLineage, information to MANTA endpoint.
That's very
so
nice.
We are now working on all these scenarios, and I think that we will need to introduce all of them and offer to our customers, which would be the best option for them.
Yeah, no, that's interesting, and I completely understand the fun and games in going, because we had a similar problem with Ageria in matching our design lineage to the operational lineage that you get from Open. I mean, it's so complementary, it's great, but yes, it was a bit of head scratching in terms of how the two were going to align as well. So, but no, it's been lovely to hear this. So thank you.
I think once you are comfortable to do this, we should add you on the OpenLineage documentation website. Listed as the consumers and producers of OpenLineage.
Okay.
Any other question? So the last part is the open discussion session. Unfortunately, we have only 5 minutes left. So I think, Suparna, you mentioned that you might have a topic for a discussion. So I don't know if you wanted to talk about it this time, or we can also add it to the agenda for next time. It's up to you.
Yeah, perhaps that is a better thing. Maybe we can, couple of things that we could do. One is we could talk a little bit about the common metadata framework, open source project that maybe Anne can talk a little bit about that. And then, what we are trying to do with integrating that with OpenLineage and with the data catalog. So we're trying to figure out, just in summary, we're trying to figure out a good way to integrate. So when we have data facets, so our first take at this was trying to record the data set facets in every OpenLineage trace record. And of course, that pretty much blows things up. And sometimes, as you see, the data set facets could be obtained. They might be static and might have obtained them from another source. We may not have all the facets described in OpenLineage, and we could keep adding more of those structures. But then we've thought that maybe having a reference facet in the data set, and which can be referenced elsewhere, and then where we can actually expand that out, and whether it makes sense to integrate more static structure, and we explored frictionless data and been exploring some other options with OpenLineage, whether that's a good way to do it. So that is one thing that from a technical standpoint we're struggling with, but we also wanted to share a little bit about the common metadata framework layer that we're building, and how we would like to connect it to OpenLineage and get some feedback from the community about it.
Yeah, that'd be great. So I think the best is you can reach out to Michael Robinson on the OpenLineage Slack, and we can set you up for the next meeting to be on the agenda. And we'd love to have a presentation of what you're doing.
Yeah. So Mandy, do you want to, I think we talked a little bit. So in terms of the problem, did I convey that?
Yes, perfect. That was great. Yeah.
Yeah, so we have very little time now, so I think let's spend the time it needs on the next meeting. And in the meantime, you also feel free to ask questions or talk about things on the Slack channel. I think that also works.
And that is why I was asking for samples, because the more examples we can see of how people are doing this. I think it gives us a bit more intuition and whether we're doing this right. Yeah.
That makes sense. Yeah, well, welcome all. Thank you for the presentations. And we'll see you all next month at the monthly meeting. And in the meantime, let's talk to you on the Slack channel.
All right.
Bye, everyone.
Okay, bye.
Bye.
Thank you.
Bye.